Very good morning. So in this video I'm going to explain the concept of normal distribution. As we know that normal distribution is a continuous probability distribution which is generally satisfies the condition of normality for many real life investigations, or what we call real life research. So when you are doing an experiment, after collecting your data, if you plot your data on a graphical sheet, generally it will satisfies a bell-shaped curve like this. Clear? So this normal curve, or what we call normal distribution, having a set of properties. So in this video we are going to discuss about all those properties. Coming to the first one, if you see this, so let's say, suppose you are doing an experiment and you have already collected the data, and if you plot all the collected data on a graphical sheet, where the sheet having all positive perceptions towards right and negative perceptions towards left, and your data may plots like this. After plotting your data, if you draw a line along with the upper boundary of all these dots, then surely your image, or what your graph represents, a bell-shaped curve like this. Clear? So this curve having a set of properties, where the first property is it's a bell-shaped curve. So if you observe this curve, it is almost looking like a bell shape. Coming to the second one, this distribution is also called as symmetrical. We call it as symmetrical because whatever data you have, if you plot the data on the graphical sheet, this distribution will divides the total part into two equal parts. So all this left part is called as left tail. We call it as left tail, and all the right part we represent as right tail. Okay, and if you assume this entire area is that the probability of this entire area is 1, let's say 100%, then if you divide this entire area into two parts, then it will equally divides into two parts. One is left tail, another is right tail, which represents 0.5 and 0.5. This means 50% and 50%. So it equally divides the area into two parts. Therefore, we call it as symmetrical. Clear? Coming to the next property. Next is mean median mode. See, for any normally distributed data, if you find mean median mode, all the three must be equal. So surely you will get mean value, median value, and mode value as equal. Coming to the fourth one, the total area. If you see this curve, the entire curve from left to right, this entire curve is representing as total area, and this total area is equivalent to 1. So in probability terminology, the total probability of your entire experiment is 1. In general sense, we say that it's 100%, and it will divides into 50% left and 50% right. And coming to the fifth property, if you observe this curve, so here this left part, this left tail and the right tail will extend up to plus infinitive and minus infinitive, and they do not touch this horizontal line. Okay, so now and these tails will extend up to plus infinitive and minus infinitive, and they do not touch horizontal line. Therefore that property is called as asymptotic. Okay, this is the next property. And coming to the last one, we call it as area property. Area property is a very important one to solve problems. So in the area property, if you have a normal curve like this, and from the center line, and the center line is representing for mean is represented by mu in normal distribution, and from this towards left the spreading is called standard deviation. So left side it is mu minus 1 sigma and 1 standard deviation. Similarly towards right it will be mu plus 1 sigma. Okay, so the area between mu minus 1 sigma to mu plus 1 sigma is always 68%. This means, for example, let's say you have collected data from 100 people, and if you plot the responses of all those 100 people on the graphical sheet, 68 people responses will fall in between mu minus 1 sigma to mu plus 1 sigma. Got it? And as we know that this is symmetrical, therefore the 60% will be plotted out of 68%. 34% will be plotted at right side, and 34 will be plotted at left side, and 34 at right side. So total is 68. So while writing in the exam, you can write the area between mu minus 1 sigma to mu plus 1 sigma is always 68%. Okay, similarly the area from mu minus 2 sigma to mu plus 2 sigma is mu minus 2 sigma to mu plus 2 sigma is 95%. This means from the central line, left it is 47.5% and right it is 47.5%. But if you observe carefully, already mu minus 1 sigma is 34, therefore the leftover is 13.5 and this is 13.5. Similarly for mu minus 3 sigma to mu plus 3 sigma, that is 99.7% that I have shown in the diagram. See, if you observe carefully here, from central line mu to the left side mu minus 1 sigma to mu plus 1 sigma, it is 68%, 34, and mu minus 2 sigma to plus 2 sigma, it is 95%. Mu minus 3 sigma to mu plus 3 sigma, it is 99.7%, and the leftover 0.3% is divided into two equal parts, that is 0.1% and 0.1% towards left and right tails. That is the area property. So here I have mentioned here, you can go through my PPT. Clear? After that, whenever you are dealing with an experiment which satisfies the condition of normality, then the unknown probabilities are calculated by normal variate, which is calculated by a formula, that is we call it as normal variate, and it is represented by Z, and it is calculated by x minus mu by sigma, where mu is equal to mean and sigma is equal to standard deviation. X is nothing but random variable value. Don't worry, this mean and standard deviation will be given in the question, and this x value we need to take based on our requirement, based on the probability which you need to calculate for a particular value. So don't worry, you can see all these three in the problem. So thank you. Problem I will discuss in the separate video.